Good morning. Today I'm gonna talk about the physics behind the microwave ovens. The physics behind the microwave oven is simple. When you add any type of energy to an atom, it vibrates. The more the energy, the more the vibrations. These vibrations causes the atom to generate heat. But there is another easier way to get the same results, and it involves using an atom's electrical charge. Water molecules are called dipoles. The water molecules are like a magnet. They have a positive and negative charge on opposite ends. This means they can be moved around with a magnetic field. In a microwave oven, the water molecules get hotter by passing short radio waves, known as microwaves. The appliance that converts electrical charges into microwaves is called a magnetron. It sends waves into the oven vacuole where they bounce around and off the reflective surface. Microwaves is like any other waves on the electromagnetic spectrum. They are shaped in patterns of electricity and magnetism that move together at the speed of light. When microwaves pass through your food, its magnetic elements ruffles the water molecules within fourth billions of times a second, generating energy and raising up the thermal energy in process. In conventional ovens, foods cook from the outside layer to the inner layer. That's why a cake could be burnt at the outside and not cooked in the inside. But microwave ovens are different because they use electromagnetic radiation with a frequency of about 2.45 gigahertz and a wavelength of about 12.2 centimeters that move through the whole meal so it cooks evenly. American engineer Percy Spencer is credited with inventing the microwave ovens in the aftermath of World War II from the radio technology developed during the war. It was first sold in 1946, but it was too expensive and not fully commercial for everybody. Thank you for listening. This presentation was done by Leita Babne.